Welcome to MOVI-C Cabinet and Decentralized VFDs 201. This is Session 9, MOVIKIT Velocity Drive. In our last session, we talked about MOVIKITs. I explained the difference between drive and controller level MOVIKITs. In this session, we're going to play with our first drive level MOVIKIT, which is MOVIKIT Velocity Drive. So let's learn a little bit about it. MOVIKIT Velocity Drive is designed for Fieldbus controlled, speed-based applications. These are applications where you're running some device at a variety of speeds. You also want some flexibility in changing speeds. The general idea is that you have a PLC out there and it's talking to the VFD over a field bus and telling it what to do as far as change speeds, change directions, and so forth. MOVIKIT Velocity Drive is perfect for these kinds of applications. It's available actually in both drive and controller level versions. As far as the PLC side is concerned, they're absolutely identical. Of course, the setup on the VFD is a little different. We're not going to deal with the controller-based one, but I do want you to know that it exists. To use the drive level one, you need application level 0, which comes on all VFDs. So basically, this is free. If you run the controller-based one, it is also a free license. So this is kind of the giveaway MOVIKIT. As a side note, it works both open loop and closed loop, so you can use it with or without feedback. It's up to you. We're going to focus on the drive level version. This one would be commonly used on VFDs like the MOVI-Drive technology we're using as our example demo unit. It also would be very common on the decentralized VFDs like the MOVI-Mod Flexible that we'll be using a little later. Let's talk about how you set up the MOVIKIT. It's relatively simple and straightforward. The first thing you want to do, of course, is perform a complete startup and just confirm that the VFD operates correctly. Once you've done that, go to the project page in MOVISUITE and double-click the bottom part of the VFD circle to attach the MOVIKIT to the axis. So you double-click it here. What will happen is you'll get a list of MOVIKITs, and the ones you're interested in are the ones under the category MOVIKIT Drive, Direct Field Bus Connection without MOVI-C controller. These right here you can see are 7 that we've already talked about. So you would pick the one you're interested in. In our case for this lab, we'll pick Velocity Drive, and then a pop-up will appear asking you which version you wish to attach. Every version from the very beginning of the MOVI-C product line up to the present will be available here. In most cases, you would just pick the latest and greatest, but if you're trying to maintain compatibility with an older system, you might have a reason to pick an earlier one. In our case, we'll just pick the latest and greatest, and then click Add. You'll then be asked, is it okay to change some parameters? The MOVIKIT actually changes quite a few, and of course, since we want the MOVIKIT attached, we'll say, yes, go ahead, change the parameters. And you can see the MOVIKIT is now attached to the axis because its little logo is in the bottom half of the VFD circle. So that clues you in, the MOVIKIT is there and ready to be configured. As a little side note, if you decide you didn't want that MOVIKIT after all, you can right-click on the bottom half of the VFD circle and select Delete from the menu that pops up, and that will remove the MOVIKIT. However, be aware that it will not put those parameters that it changed back to the original states. It will just remove the functionality of the MOVIKIT. Alright, so now it's time to configure the MOVIKIT. The way you do this is you double-click the bottom of the VFD circle. That will take you into the parameters screen, and you'll notice now there is a new menu called MOVIKIT Velocity Drive at the bottom, and it has a variety of menus and submenus underneath it. Many of these have similar names to ones in menus right above there. For example, Inputs and Outputs also appears in Functions. You may wonder, are these identical pages or not? The answer is no, they are actually slightly different. They do overlap each other, but when you're configuring the MOVIKIT, always use its dedicated set of menus, submenus, and settings pages. That will give you what you need to do everything correctly. Before we talk about configuring the MOVIKIT, I want to talk briefly about the subject of limit switches. This is a good place to introduce them if you're not familiar with them. Limit switches are safety devices. They're designed to prevent movement outside the application's normal travel limits. For example, we have a travel drive here that moves in a linear path horizontally. At each end of the travel space, there is a limit switch. If the travel drive bumps into either one, we want the VFD to shut down immediately so that it doesn't go off the track. These are common in positioning applications, but some velocity applications use them as well to detect abnormal movement. The most important thing to know about them is that they are active low sensors, meaning that they are high when you're not touching them and they go low when you touch them. Remember, active low is also the same thing as normally closed. Let's illustrate what will happen with our travel drive. We'll go ahead and start it moving, and notice that the limit switch goes low when you tap it and then goes high when you move away from it. And the same is true of the other limit switch. It goes low when you tap it and goes high when you move off it. So when you're playing with limit switches in a lab and you're using your demo control box to simulate them, you'll need to be sure to turn those switches on, otherwise you'll get an immediate limit switch trip. You configure the limit switches under the Limit Switches Settings page, and all you really have to do is pick how you want the VFD to respond if a limit switch is touched. You have a variety of responses ranging from no response at all, in other words, ignore the limit switches, to do an emergency stop with an output stage inhibit. Pick what you feel is appropriate for your application. And again, I'm just reminding you, limit switches are active low, so they must be turned on, otherwise you'll get an immediate fault trip. Alright, now let's talk about the Fieldbus side of things, how the Fieldbus is going to interact with the MOVIKIT once it's properly configured. MOVIKIT Velocity uses what we call 5 PD control when it communicates with the PLC. We call it this because the VFD and the PLC exchange 5 process data words, or PDs, in each direction. These are the process output words that go from the PLC to the VFD. The first process output word, PO1, is the control word. The individual bits in there act like switches to turn features on and off in the VFD and the MOVIKIT. Process output word 2 is the place where you send in the speed value. Process output words 3 and 4 contain the ramp up and ramp down values, so you have independent acceleration and deceleration values. Finally, process output word 5 is kind of an optional process output word. It allows the PLC to directly control the digital outputs on the VFD. This is handy if you need a few extra IOs and your PLC is out of them. You can use the IOs on the VFD, simply control them through process output word 5. Now the process input words that the MOVIKIT sends back to the PLC provide status information. Process input word 1 is sort of like the control word. It contains a lot of individual bits that turn on and off to tell you what's going on in the VFD and with the MOVIKIT. Process input word 3 often contains the fault and subfault code, or the FCB if the VFD is not faulted. Process input word 2 gives you the current speed. Process input word 4 is user configurable, so it can be set to report a number of different parameters. And process input word 5 reflects the digital inputs on the VFD, so the PLC can read the VFD's digital inputs simply by processing PI5. I'd like to point out a very handy tool that's built into MOVISUITE. It's called MOVIKIT Diagnose, and it's used for doing diagnostic and testing work. This is really handy if you don't actually have a real PLC, but you want to confirm that everything is working. Now, the Diagnose tool, which appears under the Diagnostics menu, has 2 modes. It comes up by default in Monitor mode, and all it does in this mode is it reports what the PLC is transmitting over the Fieldbus and what the MOVIKIT is sending back. It's kind of like a network sniffer tool that allows you to monitor the traffic between the VFD, the MOVIKIT, and the PLC. However, you can also change its mode and use it for testing. You turn it into a kind of PLC simulator. You do this by clicking the Activate button, and when you do that, it goes into PC control mode. The screen changes a bit, and now you can control the process data words. Process output word 1, the control word, is shown as a column of switches that you can turn on and off to flip its individual bits. Process output words 2 through 5, you can just type in values. You can see it right above PO1. You'll also see process input word 1 as individual lights indicating what the different status bits are doing. And you see process input words 2 through 5 as well. Plus there's a little handy speedometer to show you what the VFD is doing. This tool is really nifty. It allows you to do testing. You'll be using it in the lab. Without further ado, I think it's time to do a lab. So go ahead and get out your lab manual or open the PDF and then turn it to lab number 5, MOVIKIT Velocity Drive, and then pause the video and do the lab. All right, well, I hope you enjoyed that and found MOVIKIT Velocity interesting. We're now ready to go ahead and do the lab walkthrough, so I'm going to demonstrate the lab. Okay, well, we're ready to go ahead and do our lab now. As you can see, we're still in lab 4 from our last activity. So again, the very first thing we need to do is do a save as. So we'll go to project, save as. We'll call this lab 5. All right. So that's done. Let's go back to our project view, and we're going to add a MOVIKIT to our VFD. You can see right now there's no MOVIKIT here. The bottom half of the VFD circle is blank. So what we do here is we double click on it, and this gives us a list of our available MOVIKITs, and we can see we have our choices here. We're going to pick Velocity Drive. We'll click that. And we're going to pick the latest and greatest version, which just happens to be the one here at the top of the list. So we'll take that, click Add. Now it's going to tell us, do you want to allow the MOVIKIT to make changes? And of course we have to say yes if we want to install it, so we'll let it do that. And our VFD is faulted. That sometimes happens after adding a MOVIKIT because the parameters changed. We're not going to worry about it right now. We'll deal with the fault a little later. Right now we want to configure the MOVIKIT. To do this, we're going to double click on the bottom half of the VFD circle. Notice, by the way, it shows the logo of the MOVIKIT, which is Velocity. So we'll click that. And I'm going to collapse my menus. They're getting a little cluttered here. And you can see that this choice at the bottom is new. This is MOVIKIT Velocity Drive, so I'm going to expand that. And we have our different options here. Now, we don't have to set a whole lot of things with this MOVIKIT, but we should set a few things. So the first thing I'm going to do is under Module Configuration, select Basic Settings. And I'm going to do just one thing. I'm going to set what process input word 4 is assigned to. You may remember a few minutes ago I showed you what the process input words report, and I said that process input word 4 is user configurable. Well, there are some choices here. We can have it report the motor torque, relative apparent current, or the absolute apparent current. Let's pick absolute apparent current in amperes, so that's what it's going to report. Of course, this is up to you what you pick. Now we need to configure the I/O. We're going to expand the inputs and outputs submenu. We're going to pick basic unit. And first of all, we're going to set up the digital inputs. We're going to set it to freely configurable. It's already set to that. And we're going to set all these individual inputs to no function. We will change this later on, but we're going to set that here. And we're going to set the digital outputs not to freely configurable, but control via Fieldbus. That means that the outputs can be controlled by information sent in a process data word. All right, that's enough there. We've configured the I/O. Now the next step that we're going to do actually would depend on your specific VFD and Fieldbus card installed in it. We're going to set the Fieldbus card parameters. In my case, I have an Ethernet IP Fieldbus card, so I'm going to set the IP address. But if you had a different card, like a Profinet card, then you're going to do this a little differently. We need to go up here to our Device Properties menu, and we're going to pick Communication. We'll expand this submenu. We'll pick Fieldbus. We'll double-click that. And this is where we set our IP address. By default, it's set to Dynamic Host Configuration Protocol, which goes to a server for an address. We're going to change it to Saved IP Address. And then we're going to type in our IP address. And I'm going to use the SEW Eurodrive default Fieldbus IP address, which most of our products will default to. You can, of course, pick whatever you want. What's important, however, is that when we enter this information, we do not hit enter until we come to the very end. I'm going to use my arrow key to go from digit to digit, and I'm going to hit enter at the very end. My IP address is 192.168.10.4, And I need to set my subnet mask, so I'm going to type in 255.255.255.0. And then lastly, my standard gateway is 192.168.10.1, and right here I'm going to hit enter. And then finally I'll click apply address settings. It's important you do it exactly as I showed you, otherwise you can sometimes get a fault on your VFD, but because I've done it correctly, we don't have any additional faults, just the original one, which we're about to deal with right now. We'll go up here, we'll click the lightning bolt, and it just says, yes, we've changed a few things. We knew that, so I'll click Reset Device Fault. And you can see we're back, ready to run. Okay, so far so good. Now, normally, at this point, you'd plug yourself into a Fieldbus and let your PLC take control, but I don't have a PLC here, and I don't want to get into PLC programming in this particular activity, so we're going to use the MOVIKIT Diagnose tool, which is not used for normal applications. It's only used for setup and testing. I'm going to expand this menu here, Diagnostics, and I'm going to open MOVIKIT Diagnose. Now, when you open MOVIKIT Diagnose, it's in the monitoring mode. If there were a PLC connected up here, we might see some traffic coming through here, but we're not going to use that mode. We're going to use the PLC simulator mode to kind of test drive our MOVIKIT. To do this, I need to click the Activate button to change modes. All right, so we're now in the simulation mode. We're going to send information to our MOVIKIT as though we were a PLC. Let me just give you a quick overview of what we have to set up. First of all, process output word 1. We have to flip various switches here to tell things what to do. And we need to set various parameters up here, PO2 through PO5. So what we're going to need to do is supply a speed and rotation direction in PO2. Then we're going to have to give our acceleration and deceleration ramps, and then finally flip a few switches in PO1 to make things happen. I'm going to use a speed of 1500 RPM. I'll type 1500 in PO2. And then I'm going to set my ramps. I'm going to use a ramp of 500 for acceleration and a ramp of 250 for deceleration. That's going to take 3 seconds to accelerate and 6 seconds to decelerate with a 1500 RPM speed change. Okay, so let's get ready to run the motor. First of all, I need to remove the hardware controller inhibit by turning DI00 to the on position. And now we need to flip a few bits in PO1, our control word. Now, the first thing I need to do is remove the software controller inhibit. That is bit 13. This is the equivalent of the DI00 switch. It's a software switch, and this has to be turned off in order to run my VFD. So I'm going to turn this bit off. And then I need to turn my two enable bits, 0 and 1, on. I just heard a click as my brake released. It isn't moving yet. To do that, I need to turn bit 7, start stop with Fieldbus ramp on. And you can see we're accelerating. And we've run up to 1500 RPM as our speedometer tells us. So everything appears to be working just fine. Let me point out some of the feedback that's coming from the VFD. If we look in the PLC input data column, these are the PIs. You notice PI2 is telling us that we're running at around 1500 RPM. PI3 tells us that FCB5 is in control. And PI4 tells us that we're pulling 0.06 amps of current. It's also showing the status of my digital inputs right here, and it tells me I have two switches on at the moment. I have digital input 00, and I also have digital input 3, which we turned on in the last lab, and it still happens to be on. Now notice that PI1 does come back as a hexadecimal number here, and if you were a PLC programmer, that would make sense to you, and you'd be able to work with it. But the Diagnose tool makes things a little nicer. It shows you the individual bits in PI1, the status word, as a bunch of lights telling you what's happening. So let's just go down through these. Ready, of course, tells us the VFD is ready to run. STO inactive indicates we're not in safe torque off mode. Output stage enable makes sense since the motor's running. Shows us the brake is released and that the motor is running. It also shows us down here that we are at our set point speed. When this bit turns on, bit 11, that informs us that the motor has reached the speed that we asked it to go to, and right now it's at 1500 RPM, so it is at the set point. Let's stop the motor, and I'd like you to watch bit 11 here. Watch the light. I'm going to turn bit 7 off here. Notice that the light goes out. That's because we're no longer at the set point. The set point is 0 when we turn that switch off, but it takes the motor about 6 seconds to decelerate. So for a period of time there's a mismatch. But notice now that we've come down to a full stop, it's turned back on again to show us that we've now matched the set point, which is 0. Alright, I'm going to restart my motor here. Turn this switch on, come back up to 1500 RPM. And we are allowed to change our speeds as the motor is running. I'm going to go up here and change my speed to 750 RPM, hit enter. You notice we decelerate. And I can even change direction just by putting a minus sign here. That will tell me to run counterclockwise. I decelerate and reaccelerate to negative 750. That works fine. Let's go back to 1500 RPM clockwise. Notice it doesn't happen immediately. That's because we've got to go through those ramps we've specified. Now what we're going to do is try some of the different stop modes. We learned about stop modes back in Lab 4. We know that there are several kinds. There's the normal stop, the emergency stop, the application stop, and there's also controller inhibit stop. We're going to explore all of those right here and see how long it takes to stop our motor. First, we're going to do a normal stop just by turning bit 7 off. This should take 6 seconds. Let's see if it does. That's because we set our ramp to 250 RPMs per second, and yes, indeed, it takes 6 seconds. All right, let's come back up to speed. Now we're going to trigger an application stop by turning bit 1 off. That's the enable/application stop bit. If we turn this off, we'll get an application stop. And we set our application stop back in the previous lab to 750 RPM per second, so it should take 2 seconds. Let's try that. And yes, that took about 2 seconds. All right, I'm going to turn this bit back on to reaccelerate. We'll now try the emergency stop by turning bit 0 off. Now we set that back in lab 4 to 1500 RPM per second. That'll give us a 1 second deceleration. And yes, indeed, that worked. Turn our motor back on. And now we're going to do a controller inhibit stop. We're going to do the software controller inhibit by turning bit 13 on. Now this is an uncontrolled stop, so it's just going to shut off the transistors and slam on the brake. And you can see that's exactly what happened. The motor jumped a little bit. It stopped really quickly. We'll turn it back on. And let's never forget we still have the hardware controller inhibit as well, DI00. I'm going to flip that off on my control box. And notice again, pretty much the same thing happened that we got with the software controller inhibit. All right, I'm going to turn that switch back on. I'm going to stop my motor. I'm going to turn bit 7 off, and I want to point something out to you. I've mentioned that we can read the digital inputs and control the digital outputs on our VFD using process input word 5 and process output word 5. You notice right now I have 2 switches turned on. I'm going to turn DI03 off because I turned it on in the last lab and it's just still on. Notice as I turn it off, that bit changes. Okay, and I'll turn controller inhibit off as well. You can see that one went off. I'll turn it back on now. So we are reading those digital inputs. I could also type in a number here and turn on one of these outputs on the VFD. If I typed a 1 here and hit enter, it would activate one of the outputs. And if I put a 0 in, it will turn it back off. Your PLC program can do that if it wishes to manipulate the I/O signals on the VFD. That's just a handy little extra that's possible. Now we're going to play with limit switches on our VFD. We haven't worked with limit switches before. You don't always use them with velocity applications, but we're going to turn them on here and play with them. To do this, we need to reconfigure our I/O signals, and you can't work with your I/O signals while you're in monitor mode, so we need to disable things so that we can go in and make some changes. So I'm going to turn my two enables off. I'm going to turn my software controller inhibit on, and I'm going to turn DI00 off as well. My VFD is now totally immobilized. I've got to deactivate the diagnose tool, so I'll click the deactivate button and it says, hey, you're about to turn off control. Your VFD could run by itself. Are you in safe state? And I'll say, absolutely, it's okay. I've made it safe. So I've deactivated. And we're going to go up here to basic unit and we're going to reconfigure our I/O signals. We're going to assign the limit switches to DI02 and DI03. I need to do something first. I need to turn those switches on my control box both on. So I'm going to turn 2 and 3 on. That way my limit switches won't trip the instant I assign them. And I'm now going to set DI02 to the hardware limit switch positive. And I'm going to set DI03 to hardware limit switch negative. Now if I turn either of those switches off on my control box, it will trip a limit switch fault. All right, I need to go back into MOVIKIT Diagnose, reactivate it, and I need to get my motor running. So I'm going to turn the DI00 switch on my control box, turn off software controller inhibit on bit 13, re-enable things, and I'm going to type in my speeds again, 1500 RPM, 500 RPM per second for acceleration, 250 RPM per second for deceleration. I'm going to start my motor running by turning on bit 7. And we accelerate up. And now I'm going to simulate touching a limit switch. I'm going to trigger the clockwise limit switch, that's DI02. I'm going to turn it off right now. And boom, you see we had a limit switch fault. Notice up in PI3, instead of FCB05, we have 29.1. That's the fault and subfault code. And over here, the tool tells you that's a limit switch positive hit. So we did indeed touch that limit switch. Now we're going to clear that fault. I'll turn my DI02 switch on, so we're not on the limit switch anymore. But we're still faulted. I have to reset my fault. Now I could do that in MOVISUITE, but you can also do it over the Fieldbus. There's a bit in P01 called fault reset. And if you toggle this, turning it on and then off, clears the fault and your motor resumes operation. Remember, clearing faults always restarts things, so always be conscious about that. Be careful about it so you don't have something undesirable happen if it restarts. Now I'm going to show you something else that's kind of handy that you can do in real applications. Let me trigger that limit switch again. I'm going to turn DI02 off to simulate touching the limit switch, and I'm going to show you that you are allowed to back off the limit switch. What I'm going to do first of all is reverse my motor direction by setting my speed to negative 1500 RPM. And I'm going to clear my fault, and you'll notice that even though I'm still touching the limit switch, because I haven't turned DI02 back on, it will actually restart the motor and back away from it. And now I'm going to simulate coming off the limit switch by turning DI02 back on, and everything is great. You can do that. You can back off a limit switch as long as you go opposite the direction that you were traveling when you tripped it. All right, we're going to stop our motor. We're going to disable it, activate software controller inhibit, turn off DI00, deactivate our tool, and save our project. And that is the end of our lab walkthrough. All right, before we wind up this session, I want to make one post-lab comment. I want to talk a little bit more about limit switches. You may not have noticed this if you haven't run into it, but the VFD is actually rather clever about limit switches. When a limit switch trips, it doesn't just fault, it also evaluates whether that limit switch trip makes sense. For example, if you're moving clockwise and you hit the counterclockwise limit switch, that doesn't make sense. It suggests that something isn't working correctly. So let me illustrate this. Let's say that we're moving counterclockwise and we hit the left limit switch. That makes perfect sense, and so you just get a normal limit switch fault when that occurs. And if you go the other way, clockwise, and you hit the right limit switch and you get a fault, that too makes sense. But what happens if you're moving counterclockwise like this, but you trip the right limit switch? That doesn't make sense. And so what the VFD will do is it will put up a totally different fault code saying, hey, I think the limit switches may be wired backwards. And that is helpful because that can clue you into mistakes. So just an interesting little thing that may actually help you out down the road. And with that, we're done with session 9. We're also done with the cabinet portion of our class. We're going to move into the decentralized technology in the next session. We're going to be learning about the different decentralized VFDs and their accessories, and then we'll do a series of labs involving those. So, see you next time.